Everybody, welcome to Cloud Networks Made Simple with Riverbed on AWS. Nick Matthews, I'm a solutions architect here at AWS. Just a couple housekeeping notes here. If when you came in, you have the option to come in via direct voice or IP audio or dial in. You can switch that anytime. That's up in your control panel, probably up in the upper right. And then during the presentation, if you have any questions, feel free to put them in the question area. So myself and some of the other folks on the call will be monitoring that, and we'll try to go through some of those questions while we're going through the call as well. To answer some of the frequently asked questions, these slides will be posted to SlideShare. It might take us a couple days to get it up there, as well as the recording. So you'll get a copy of that a couple days after this concludes. So let's go ahead and get started. So I'm Nick, I'm solutions architect here. I work with our networking partners on AWS. So let's get started with some of the AWS sort of networking basics here. So the high level, a lot of you guys probably are familiar with AWS, but some of the real big benefits to AWS are the scalability, being able to come on AWS, use the resources you want when you want them and only pay for what you use. Security is increasingly another driver as more folks are realizing that they can actually build their infrastructure and their security more securely in the cloud than they can on premises. As well as if you want to go global in minutes, like we like to say. AWS allows you to do that. We've got 14 regions and around the world. So in terms of networking, that also starts applying to things like our points of presence, where we've got points of presence for both CloudFront sort of CDN type of activity for caching, as well as if you want to connect your on-premises networks into AWS. We have a number of different places where you can hardwire in your existing MPLS, VPLS, or just VPN in all across the world, so you can create a global network very, very quickly with us. As well as the cost effectiveness due to scale, and also some of the ways we end up doing our infrastructure of paying for only what you use. It makes it pretty effective for doing that. And again, in the terms of networking, you don't pay for the networking you use, so you're not having to sort of get a crystal ball out and guess how big your network needs to be and however many years, or you're not paying down for large capital expenditure for networking infrastructure just to support some amount of applications which you're not sure how much you'll use. So I think all these still apply actually in the networking world. If we dig in a little bit further, some of the base building blocks we've got in the networking world is Amazon Virtual Private Cloud, or VPC. That's sort of your where you put all your instances. That's where everything lives. That's your virtual network. We've got AWS Direct Connect. So I was saying before, when you wanted to maybe bring in your existing network into AWS, this is how you would do it. We'll go into that in a little more depth. We've also got the Amazon Elastic Load Balancing service, so that you have a scalable way of load balancing all your network traffic to your instances and your servers and virtual machines and whatnot. And then Route 53 is our hosted DNS service. If you take a look at sort of the hierarchy of the way things flow inside of it from a networking perspective, is first we start with a region. So a region is a collection of our availability zones. Availability zones, they're easy to think about as maybe a data center. Many of our AZs are actually collections of data centers, but the important part is from an application perspective, data center is not a very important term. What you do care about is fault tolerance. So our availability zones are built so that any given availability zone doesn't share any fault domains with any other availability zone. So things like flood plains and upstream electrical providers or upstream bandwidth providers. So within a region, we've got a group of availability zones. Each of those are all don't share any fault tolerance. We get a collection of those, at least 2 of those in any given region, and that makes a region. So we've got 14 regions across the world, and I believe 46 AZs now. That we're always continuing to sort of expand that so that network keeps changing and going up. Inside your region, you create your virtual private cloud. And we'll get in a little bit more depth on what that means here on the next slide, but inside your virtual private cloud, then that's where certain things start to look familiar from a networking perspective. You've got subnets where you can create a specific routing policy per subnet, as well as you can start applying security per subnet with things like the network ACL. Those are stateless sort of IP blocking mechanisms. And then you've got security groups which can be applied per instance. So that allows you to define which applications maybe a traffic source should be coming from or going to, as well as being able to block ports that you wouldn't want someone to access your instance on and whatnot. If we take a little bit closer look at what VPC is, it's effectively, it's like creating your own data center in the cloud. So every time you create your own VPC, you have a segmented area. So, large enterprises like to use this for sort of segmentation, maybe between business units, between maybe compliance areas, so maybe PCI and non-PCI would be in different VPCs. As well, when you create a new account on AWS, you get a new VPC with each new account. So if you have sort of a structure that defines many accounts, maybe for a billing perspective, or maybe just for a blast radius containment kind of for perspective, you'll end up with a number of different VPCs. So much like on-premises, if you have lots of data centers distributed across your environment, connecting to those becomes sort of a networking challenge that you will want to create an architecture for. So that's sort of what we've got Riverbed here to help us sort of take a look at how they help with that. Some of the additional services here are Direct Connect. So this is primarily for customers that want to either increase their sort of bandwidth by having a dedicated circuit between their on-premises maybe data center and AWS, or for folks that really care about latency and performance characteristics of a private circuit as opposed to using internet. But we're also seeing a large amount of movement in the networking industry towards IPVPN and VPN-based approaches, as it's quite often more convenient to get internet circuits than it is private circuits. And so we've also got options to do sort of and we'll talk more about this in the rest of the seminar, but distributed VPN across lots of locations, and how do you manage that, and how do you secure that across lots of places. As well, we've got like I said, our elastic load balancing. It's the primary benefit here is that it scales out. So if you put all your instances in an auto scaling group, so that as you get more demand into your web service, you don't have to worry about scaling it up and with sizing and those kind of things. It works with our auto scaling to sort of use metrics to figure out how many instances you need to shrink and grow as you need. And the load balancer is something you don't have to worry about sizing that as well. And it's highly available. Route 53, sort of similar approach, but for DNS. If you want to use either private DNS inside your VPC, or if you want to use DNS outside your VPC, we have a managed DNS service, which is Route 53. So it's nice if you need that sort of thing. So if we take a look at the sort of services, that I end up working with in the partner world is a lot of folks that come into AWS to extend our routing capabilities. The routing capabilities inside of VPC is you can route to an ENI. You can use we have a managed VPN offering that offers some services as well, but there's still a lot of use cases for routing. For instance, if you wanted to transitively route through a number of different VPCs, so if you wanted to centralize maybe one VPC for ingress from on-premises and then have that sort of fan out to many different VPCs, that's a common use case for marketplace offerings on AWS, as well as VPN. There's a number of different VPN sort of extensibility options and configurability, and just there's lots of flavors of VPN. Some folks will want to use their VPN for additional security, encryption, as well as flexibility to on-premises. And security, you can never have enough security, and everyone's got sort of their own security requirements. So a lot of these networking options actually offer additional security benefits above and beyond what the native, or sometimes in conjunction with the native AWS services like CloudTrail, VPC Flow logs, security groups, and network ACLs. So to kick us off through a story of how folks are doing this, we've got Craig from OpenEye, who's going to talk about their use case and talk about the networking. So Craig, go ahead.
Thank you very much, Nick. Yes, my name is Craig Bruce. I'm from OpenEye Scientific, and I'm going to talk you through how we started using the Riverbed solution to help with our growing challenge of increased number of VPCs and multiple accounts in multiple regions, and how this was becoming a little bit of a challenge for us. Hopefully my slide will advance. But to tell you a little bit more about OpenEye, we are a company here in the US. We work in the pharmaceutical industry, and our customers are Fortune 500 biopharmaceutical companies. They're very large, very enterprise-centric, and we're providing a solution for them that they can install in their own accounts, or we can host it for them using the AWS platform. And despite working so closely with this, you might be surprised to hear that OpenEye as a company has no dedicated network engineers. We're a small startup, we've grown organically, and using AWS is an amazing platform for that. But some of these things are incredibly technical and incredibly precise, and that's when network engineers can become very useful. But using the Riverbed solution has made that a little bit easier for us. So to dive in a little bit more about the VPC, so this is sort of taking next diagrams, explanations, but going into a lot more detail. So here we can see the Amazon region on the outside. We have a VPC, and within this VPC there are two subnets. And the big difference here is that the top one, where you can see the web servers, is a public subnet. This one has an internet gateway attached. It's publicly accessible. And in some regards, this is very analogous to EC2, which is the default way of creating instances. But since the VPC technology was added several years ago, this has been a real boon for enterprise, specifically for the lower part, the VPN, or a private subnet. Now this gives you a lot of restriction over the accessibility to these instances, so you can keep your machines out of a public internet, which, as an extension to your data center is really important. The catch is that now you need a way to get in yourself to this subnet, and a VPN, Direct Connect, and Riverbed can help with this. But all of these are more complicated than just a public-facing IP. Nick also alluded to some of the other technologies available for the VPC solution, and that is the ability to pair VPCs with each other. So you can come in through one and then reach another VPC by jumping between them. And that could be in this very simple solution, and we originally had a solution like this. VPC A was essentially our internal VPC, and then VPC B would have been our production VPC. So we jumped and restricted access to the production VPC. But you might have a much more complicated example, and the peering is not restricted to a one-on-one. You can do it in many different forms and different directions, and while it gives you a lot more flexibility, it obviously gets a bit more complicated to set up as you go along as well. So the other way to get access to your private subnet is not to come through the private subnet directly through a VPN, but to actually come through a public subnet. And you can do this using Bastion host. This is a very common approach. There's actually a great blog post on the AWS website about using Lambda to basically trigger a function to open up a security group rule from the IP you're currently at, so you can restrict access to that Bastion as much as you can because it is public facing, and even maybe just turn it on, open up the security group port for the IP you're on, let you do your work, and then run it again to close the access and turn off the port, turn off the machine. And while that is one way of doing it, personally, I've always found if you don't need to go through the public internet, that is always better. You want to keep your traffic encrypted and just complete disconnect between your public and private subnets. So as we looked around and our original VPC, we do have a VPN connection with Amazon through the VPC product. You can go on there, you can hook up your various hardware, your Cisco routers. They support various hardware that you have already. They'll give you a configuration that you can connect it up, or you can use Direct Connect, and that's really good if you have a lot of bandwidth. But our use case, we didn't really have a lot of bandwidth. It was more about connectivity, because I have these different VPCs in different regions, in different accounts, and each one therefore started needing a unique connection, and that just did not work with a one-on-one VPN connection. And Direct Connect for us wasn't quite the right solution, since it was about the high bandwidth, which wasn't a challenge for us. And as a smaller company, the pricing was less favorable. So what we discovered was the software-defined WAN arena offered some really interesting options, and we wanted a solution that was supremely flexible. I might want to create a new Amazon account today with a new VPC and have a VPN connection running within an hour. that's really tricky if I've got to go and change the setup on my Cisco ASA. That's not a 1-minute piece of work. That takes a little bit longer, and in a larger company probably involves change control, and it's not quick to do. We also found we were having restrictions to the number of VPCs and regions we could connect to, and again, we don't want to be restricted by that. AWS has a huge global footprint. I want to be able to use any region that I require to help my customers get their work done. If we're using a third-party solution, it's really important that we have tight integration with Amazon. It should know what a region is. It should know about VPCs. It should know about the subnets, and it should integrate with their policies directly. So that's important to us. Ideally, we already have lots of Amazon accounts. We already use consolidated billing, so we already have a way of getting our bill from Amazon. I don't want to be adding lots of vendors on separate contracts, on separate invoices. So using the AWS Marketplace, I can very easily agree to terms and additional payments, and they'll just come through on my regular consolidated billing, which is easier for me and easier for our finance department. Obviously, I'm going to have to give some access to my different accounts to the third party. And if we're going to do that, we want to follow best practices. And best practices for that is no longer giving them keys to your account, but we use the IMA roles instead. So this way, you're never actually giving them a direct key. You use the role system, which is a much better way to do it. And finally, just as I can programmatically create new Amazon accounts using AWS organizations, I can create VPCs using CloudFormation, I want to set up my VPN access programmatically as well. I'm a DevOps engineer with my other hat on. I want to be able to do everything automated and get up and running as quickly as possible. So programmatic access through the solution is also important to us. So looking at this long list of requirements, we looked around and came across Riverbed and found that the SteelConnect solution was a really nice overlap with the different things that we wanted to do. And we did a trial and now have it successfully running. We have it running in multiple accounts, multiple VPCs, and now we're up and running. I really can add a new VPC to our internal network for connectivity in a matter of minutes. So with that, I'd like to hand over to Angelo, who works with Riverbed. He's their Technical Director of Cloud. He's helped us get on board with the project and is really excited about the integration with AWS, a lot of which has been added in the last year, which has made the product even better. So Angelo, I'll hand over to you.
Hey, thanks very much, Craig. I really appreciate it. So yeah, as Craig said, my name is Angelo Comazzetto, and I'm the Technical Director of Cloud here at Riverbed. I'm basically responsible for the design and the direction of a lot of our cloud efforts when it comes to how we integrate with SteelConnect. And some of that we're actually going to show live for you today. We're just going to get through a couple of quick slides here and see if they'll advance one for us, and so we can chat through some of these points. So basically what we wanted to overview before we just dive into the demo is just a quick high-level view over a couple of slides, just what SteelConnect is. So basically SteelConnect at its core is a very intelligent automation management system, and all of the things that it interacts with have been built from the ground up to work with SteelConnect. So unlike other multi-managers you might have heard of, we don't build things for other products and try to interface with their APIs and get caught by version and changing. Those kinds of products tends to be fast followers or slow followers or broken followers, if you will. So we actually make gateways which connect you together, connect VPCs together, connect on-prem sites into the cloud, connect on-prem sites together, all sorts of cool stuff there. And we also do kind of an SD-LAN piece as well, where our switches and access points can be fully orchestrated and work together with the SteelConnect Manager. So today we'll talk quite a lot about SteelConnect Manager, which we call SCM, and the components of that really allow the SteelConnect gateways to talk to each other in a very automated fashion. So think of it as a chessboard, where if you're just one piece and you're kind of looking at the ground, you can't really see what's around you. But if you have an eye in the sky above it, the overall strategy and how all of the pieces are available to move can be made much easier. So with our gateways and all of the pieces that we have on the board, the key is the SteelConnect Manager that actually instructs them how to do their jobs, sends the config files down to them as you make changes, and basically exempts you from ever having to log into an individual device and create policy or do tweaks ever again. So the use cases for something like SteelConnect are anything where there's an SD-WAN or a hybrid WAN design, if you're looking to mix internet connections with MPLS stuff, if you're actually looking to move away from MPLS and onto a pure multi-broadband type connectivity, we can do that for you. One of our strongest parts and one of the things that's most popular about SteelConnect is the way we do cloud connectivity and how we think about enabling that for you directly from the console and how we can even help you move some of the plumbing around in your Amazon account. We're going to demo that today here in just a minute. And of course, there's branch networking. Anywhere you have lots of offices, you need to connect them together. And just like many things that Amazon does, it is possible to do things in an inefficient way. You can log into devices and you can do things by hand. And AWS really recognized that virtualization and mass scale computing and storage and all of that could be their problem. And they could make that their problem and just charge you a few pennies for that. And so Amazon's key to their success is their automation, the way that they take certain mundane and tedious tasks that are technically possible for you to do yourself, but they just make that not your responsibility and let you leverage their platform to work less so that you can work on things that actually need your attentions, and not things that are very, very difficult to do just at scale. So I'm going to dive into a demo. So what I'll do is I'll just share my screen here, and that'll allow me to show you what a SteelConnect Manager looks like. And from there, we can actually take you through a small tour and show you what's going on here. So just take a second for that to load up. And what I've got today is I've got a company here that we call Global Research. It'll just take a second for that to sync to everybody in the audience, and you'll be able to see what I'm doing on the screen. And basically, this is SteelConnect Manager. And here is where you can do everything around your company to manage your network. Now, the company we have today already has several sites deployed around the globe. We call them Global Research. These sites are all connected together, and if you actually start clicking on the sites, you will see a little bit of an indicator as to how they're all joined. We just don't show all of that on the map by default because then that could be quite difficult to figure out which lines go where. So as you click, the map will adjust to show you the topology you're interested in, and there's a bunch of metrics and stuff that we'll explain to you in the demo here. I'll give you just a very quick overview for 2 or 3 minutes to show you exactly what it looks like, and then we're going to kick off a deployment, and then I'll talk through some of the things that are going on while the deployment happens, and we should be able to, with the time we have available, see that deployment actually finished. So yes, in our demo, we will actually add a VPC to our company while I'm talking to you, and it'll happen all in the background. So in SteelConnect Manager, we have some different sections here. The one we're going to focus on is network design. This is where you can see the sites, and in SteelConnect, sites are just places where you have a presence. One of the benefits of software-defined approaches like this is you don't have to worry about configuring an appliance, configuring its interface, plugging it in, getting it online, all of the things that you would do with a normal site. Here you can design and you can build your whole network completely without an appliance and then simply add an appliance later when you're ready. So the point I want to show on the sites here is we have no AWS sites. They're actually called AWS when we do launch them. And we have sites in all over the world, from Cape Town to Hong Kong to Los Angeles. And these are places where they have different networks in place. They have MPLS lines. They have uplinks. We separate all that completely out. So if I do want to see an existing traditional uplink and see what that looks like at a physical site in Berlin, we can see that it does have an uplink and it has an IP address. And all of that can be done independently of the actual appliance. And in fact, when we show you the appliances a little bit later, you'll see how we've managed to abstract all of the pieces of the networking away from the appliance. And the reason for that is that ultimately the appliance is the thing which simply executes the configuration. So the traditional way of thinking, which is the appliance has the config, it must be backed up, it must need a special key in it, and all of the things that you might be used to on a physical appliance, those go away with SteelConnect appliances, because if you were to pour coffee on one, for example, you could simply register in another one, the config would sync back down and you'd be back up and running, or use one of our high availability options as well. So as you're looking through this demo, several things might trigger your interest, and we have the ways to answer questions, and we can make sure that everybody gets an answer to their questions today. So if you do have any, feel free to ask. But as we're going through here, I'd like to kick off and show you the main reason why Craig was speaking to you today, which is a little bit about the AWS integration. So the first thing is I'm just going to go down here to our section cryptically called AWS. And we take security very seriously. We're security people. We've been doing security for years here at Riverbed, and there's no point in having a solution that's super cool if it's a security risk. So unlike a lot of implementations, you shouldn't use things like access keys. Those can be stolen. Those can be posted on the interwebs. All sorts of things can happen with those. When you want to join your SteelConnect Manager to your AWS console so it's able to actually make educated decisions and do the automation that you're asking of it, all you have to do is go make a role. And when you make a role, we actually ask you to do that with IAM. And the reason for that is it's seriously the most secure way that you could do that. And so when you want to add an account, we instruct you what to do. We tell you to go into your AWS account. You create an IAM role. We ask for some permissions, and you can tighten those down if you like. And then from there, you come back with your unique identifier, your ARN, and you paste that in here. And when you've done that, you'll see it here on the page. And the reason we show them here is that it is possible to subscribe multiple accounts. So if you have VPCs across many accounts, you'll be able to see them all here and actually connect them together all from the same console. So using an IAM role is great because A, all of the communications that we do to your AWS account are done via the AWS command line. That means in addition to our own logging and the own things that we put in place, you have full CloudTrail logging for everything that's happening in your network. We have a very interesting approach to try to do no harm to your network as well, or do no harm actually. It's not an attempt, it actually works that way. But we'll show you that in a second, but the point I'm trying to make is with IAM, you are in full control over what this SteelConnect manager can do to your network. You have full logging over every single command it issues, and that allows you to very quickly trust the automation and ensure that it's not going to carpet bomb your network with a bunch of unforeseen changes that you didn't want. So,
hey, Angela?
Yeah, go ahead.
Hey, we had a question come in. They want to know a little bit in terms of security, what other type of encryption options you guys have, maybe from an encryption in transit or what are the encryption options you guys have?
Yeah, so across the security product, if you want to be a bit more specific, we can definitely dive into it. But when it comes to connecting the sites together, we do use AWS VPN. We use SHA-256. We use elliptical curve cryptography. So we use basically the most secure VPN options available to mortals kind of thing, unless you have a dedicated solution from maybe a private company. But at the same time, we layer security throughout the whole product. So connecting it to the SCM, to the AWS console, is done in the most secure way using the cross-account IAM rules for third parties. There's two-factor authentication available for the SteelConnect manager, requiring you to every single time log in, verify with your mobile or your email address. So there's a full security and routing engine in the product as well, from a firewall all the way to a very detailed traffic path steering mechanism as well. That's obviously way too much to show just in one demo today, but yes, security is seriously job one here at Riverbed, and that's where Amazon and us share a very common philosophy.
Cool.
So let's show you some magic. So once you've joined your account, what you're going to see on the next screen is the place where you can connect VPCs. So here is all of my VPCs in all regions, and I can see them, I can select them, and still we haven't made any changes to an AWS account. This is just where I get a listing of all of the things that I can add into my company. Now in this case, the VPC that I want is actually located in the Northern California office. So let's look for US here. We find US East. Let's go down and find US West. And here's the Northern California Apps VPC. And I actually do want to connect that to my company. So I'm just going to hit connect. And what this does is it does the things in SteelConnect Manager for me. It doesn't change anything in AWS yet. You'll see some log information down below. But basically it's going to do things like create the site, import the networks, in this case this CIDR block of 10.6.10.0 as a zone for that site. It adds the uplinks, and it basically gets SteelConnect Manager ready to have a gateway appliance plugged into SteelConnect. So if I actually connect another one here, we'll connect the development VPC. Let's go for one farther away. Maybe we'll use one in Canada. Or actually, why don't we use one a little bit farther here? We'll use one in Tokyo, just because then we'll get a nice line going around the world. Let's say that we also have a subnet here in Tokyo we want to connect. We connect that. And while that's connecting, if we go to sites, we'll see that before we didn't have these sites, and now we have one already. We have a site now for the Northern California and for Japan. And if I want to look at something like the networks and pick that site for Northern California, it's already imported the CIDR block for me, and basically SteelConnect is ready to receive this appliance when it boots up. And so let me do that, and then I'll talk through a little bit what's happening as it does it. So we've connected the VPCs to SteelConnect, but we haven't done a deployment into our Amazon cloud infrastructure yet. So we're going to do that, and so the automation has time to boot the instances and patch them and do all the magic stuff. So here, what we're going to do is we just have to click deploy, and this is now going to interface with my AWS account. So we support different gateways. We have some recommended throughput numbers. These aren't hard limits. Different instances can burst and do all sorts of cool stuff, like T2 instances, if they have credits, can burst much faster than what we display. This is kind of like the minimum throughput that you're almost guaranteed to get. So what I'll do is I'll deploy one of our large instances here that gives me around 200 megabits sustained. The T2 large can burst a bit higher, but also drops if it runs out of CPU credits, depending on how much VPN you're asking of the instance. So I'll drop the C4 large in there. We also have the ability to, right behind our gateway that we deploy in your VPC, to actually optimize that traffic. So if you are using Steelhead, or you're not a Riverbed Steelhead customer at all and just want communication between VPCs in different regions, and you want that to happen with Riverbed's award-winning kind of WAN optimization solution that kind of redefined how WAN op would look when it was built and still leads the market today, you can do that just by deploying something here. So I'll grab an extra large instance there. And again, these are just estimated throughputs. Redundancy is important. It's on by default. And of course, we want 2 of everything so that we have multi-AZ failover for this. And I'm actually just going to hit submit and get that deployment kicked off. And very quickly, we'll do the same thing. We'll use the exact same template here on the other side. We'll deploy that one as well. And here's what's going to happen now. So before, if I just look at my management console here, you'll see that I might not have an instance yet. I have no instances here in Northern California. So in a second, we're actually going to see instances be placed in here by the SteelConnect manager as it executes its task that it needs to do. So the first thing the automation is going to do is down here under appliances, it's going to create some appliances for the sites. So you can see here we have an appliance, not a real one. It's a virtual gateway in AWS. It's not online yet, but when it comes online in AWS, the appliance will automatically register with SteelConnect Manager. It will patch itself to the latest version, and then it will proceed to build a VPN automatically to all of the other sites in the company. We can also do hub and spoke and kind of breakout or bastion topologies as well, but I'll leave it as full VPN for right now as a full mesh, because also there's a policy and a permissions thing on top of it that it controls access. So just because you see lines going to all sorts of sites doesn't mean that these appliances are actually going to provide unfettered access to your networks. So it's booting up, and we're going to have a look here and see. If we just refresh the Amazon console, we should see there's a couple of SteelConnect appliances booting up. So we can see right now, if I just go over to here, we've got a gateway and a Steelhead running in 1B, and then the other ones for the redundant operation will load in just a minute. So these are going to boot up, and it's going to take them a minute to provision, and then they have to reboot. Now, our physical appliances can actually finish this whole procedure in a minute or 2 at the most. It takes somewhere about 5 or 10 minutes a little bit in the AWS environment just because we're limited by how fast these machines can actually boot. So from back in SteelConnect Manager, the logs are scrolling like crazy as it's doing all sorts of good stuff for us. The appliances will come online and offline a few times as they get things going. And then at that point, we'll be able to move past it and show you what it actually looks like in the actual real world as it's actually working. So the appliances are booting. We start doing some route information now. And let me explain what's happening in AWS. So the first goal that we had is this solution could not do any harm to your network. So what we do is we look through your network, and you'll see here was my VPCs here, and I have a route table. If I actually look at the subnet though here, I'm actually going to have some dedicated SteelConnect subnets. So we create a dedicated uplink and downlink subnet in your VPC. We do not launch our machines into your existing subnets that you've wanted to connect. So what we do is we build an uplink and a downlink subnet. We launch our appliances into that. The appliances then have a full communication, a full security suite, all of the good stuff that comes with AWS. And at the end, when the appliance is ready to receive traffic, what we change is we change the routes of the subnets that you've connected to point additional networks available in the company to our gateway. So these are networks that otherwise are going nowhere, and we attract the traffic into our gateway, which then disperses it to the rest of the company based on the Amazon route tables. We also have an option called manual routing, or if you have too many routes for the AWS route table to scale cleanly, you can enable manual routing, and that would then cause you to have full control over the routes and the gateways to be sitting there ready to route traffic for you. So we monitor, we deploy everything into our own subnets. It's our own appliances. The only change we make to your AWS configuration is we will edit the route tables for you if you want us to. That means in the exact same manner that you deployed, if for whatever reason you want to undeploy, if you want to resize an instance, if you want to add a new VPC or remove one, the entire process is fully reversible without any side effects that you would have to cut out of the Amazon console. You wouldn't have to log into the console and actually change things. So if we come back here to the dashboard, we can see that our sites are provisioning. Now they don't have tunnels yet. It's got no connectivity. They're still booting up. And when they do that, they indicate that they've got a problem. It's not really a problem. They're still under construction. But these lines will start to turn green as this new AWS VPCs join the company framework in a full mesh. And that'll happen once they've been online for a couple minutes. They just rebooted a few seconds ago here. And of course, they're in a high availability mode. Now, once the appliances have fully booted and built the tunnels, you then get some very detailed metrics. So if you're using WAN optimization, you can drastically reduce the amount of traffic that's flowing between regions across the tunnel, or even within region in the same region itself as you're moving traffic through VPCs. If you're using the Steelhead appliance that's in there, that will also allow you to very easily reduce traffic between VPCs that you're moving files to and from directly.
One of the questions that came in, sorry. Yeah, one of the questions that came in was, what type of devices can you connect to? Do you have Steelhead connect devices on-prem?
So, well, Steelhead does automation for our own appliances. Like, we will automatically update our gateways. We'll make changes to switches and access points in the console itself here. If you do want to talk from an outside device into the SteelConnect environment, we actually do that here with a section we just kind of tongue-in-cheekly call Classic VPN. And this is when you could actually build a straight IPsec VPN using a more traditional way that you might be used to in any of the UTM devices or dedicated routing appliances. You can connect those into a single point of entry in the SteelConnect ecosystem, and we'll handle, as always, all of the transitive routing for you and all of the forwarding. So yes, we fully support that. You just find it here in a bit of a section where you have to go as an effort.
Great. And then one other question that came in was, how much latency does having the controller introduce?
Oh, well, the controller itself doesn't really do anything. That's actually a really good point. So the controller is completely an eye in the sky. So just like on a chessboard, if you're moving a pawn forward 2 spaces or a bishop diagonally or something like that, the eye in the sky doesn't have to take the piece and transit it through the manager. So the manager is simply it's getting telemetry back, and it's getting intelligence on how to make automation, but all of these VPN tunnels are all directly connected to each other. So that means an appliance on site goes to another appliance on site, and the SteelConnect manager adds no latency into that because it's not directly involved in the ongoing communications. That's a very good question and important to note. So it looks like some of our sites are coming online. So if I come back here, let's just have one more quick nerdy deep dive. I'll refresh this page here. You can see that we have 4 appliances now, where before we had none. So we have our Steelheads coming online, and we have our gateways coming online. But the cool part is the routing that we do. That might just kind of indicate to you what happens. So I connected this, Angelo. Oh, actually, I think I connected, let's look at a certain VPC here first. I connected one called Apps. So if I look at the VPCs here, we have this NCAL Apps VPC. So this is the one we've connected. And this is what we want to publish the applications that we're running to the rest of our company. And so if I actually go to the route tables, and then actually the route table for that, we're actually going to see here, you can see that the routes themselves have already been added. So all of these networks have been added into the system, and these are all pointing to our interface. So we're attracting traffic for the rest of the company by telling the AWS route table to send that traffic to our instance. And then from there, the built-in router and the built-in VPN engine in the appliance does all of the work for you. So you don't have to know anything about routing when it comes to this particular application. It's always good to know some things about routing, but you don't have to know how to plumb all this together. You don't have to do manual setup in VPC. You don't have to do your own routes unless you really want to. And in fact, the entire process is automated from end to end. So while I've been talking to you here on the phone for the last 9 or 10 minutes, we've successfully connected 2 VPCs in 2 totally different regions, to each other, and also to the rest of the company and all of the sites in the company. This means if I was to click here, my site in Seattle now has a dedicated path over to the AWS VPC in Tokyo. And because SD-WAN provides you a very high level of visibility, if you actually click on a given tunnel, you start seeing metrics as to what kind of things we are seeing in the latency itself. So we can see here the VPC to Seattle. It currently has almost a 237 millisecond round trip time, which is quite good. Amazon's quite fast across the ocean. And if we want to reverse that behavior and see what that looks like in another direction, we can just click the reverse button here and see there's almost no jitter. There's no packet loss. We're not really sending any bandwidth through here just yet, but you get very detailed metrics, and that's just some of the intelligence that we use when you start to dictate if you would like to also use our solution to route applications in a certain manner, or if you'd like to use our firewall to build graphical rules. We don't touch your Amazon security groups. You would have to make allowances for those. For example, if you want traffic to flow between Japan and to the new VPC that you've made over here in US, I think we deployed over here in US East, I think it was. I actually forget which one I connected. There's been a few. So we connected 2 different VPCs and right there. So if we see that one, we can see that we have our own security policy engine built into the product between them. But your own security groups in AWS, you would actually have to open those. So we don't open your firewalls. We don't change your precious security configuration. We believe you should do that. But if you'd like to open those security groups a bit yourself and then use our graphical rules engine, that's no problem at all. We highly encourage you to do that if you like. So the one thing that I did want to mention is all of this is available in the Amazon Marketplace. And we'll tell you at the end of the demo on how you can get your own SteelConnect manager and just run off to the races and start deploying stuff in the cloud without ever talking to anybody here. But you can also find us in the Marketplace, and you can see all of the pricing and all of the things around both the Riverbed SteelConnect Gateway and the Riverbed SteelConnect Steelhead. One of the questions is, can I use the Steelhead as an optimizer without the gateway? While Riverbed does have a dedicated cloud Steelhead product, the SteelConnect Steelhead is deployed in line with the Riverbed SteelConnect Gateway. So you always will deploy a gateway with this solution, and then you can choose whether or not you want to add the optimization for a little bit more per hour. Both are marketplace products. You can remove them, change their size, turn them off as all of the good things with the Amazon Marketplace. You can do that as much as you want. No need to buy new licenses or put new keys and such in there. So all of this has been logged in CloudTrail in the exact same manner that we set this up. I normally don't turn AWS stuff off, but we'll do it here today. We can actually, at any time, we could change. We can add redundancy, remove redundancy, which you should never do. You can change anything you like at any time. However, if you like, you can also remove one. So clicking the undeploy button will terminate all the instances, remove any routes that we might have made for you, clean up everything in SteelConnect Manager, and in 2 or 3 minutes, there will be no trace that this VPC has ever been talked to by the SteelConnect Manager. Of course, the rest of your company won't be able to see that VPC in almost a direct, nice, easy fashion, but that's some of the trade-offs that you make, and very few people do choose to undeploy once trying it out. The point is, very easy to demo, very easy to take a shot at it and not have to worry about it messing up all of your architecture that you've worked months on perfecting. And if you want to very quickly provide access to a VPC or plumb a whole bunch of VPCs together in a number of different architectures, we would be happy to tell you more about how that would do. So I know that we have time for a few questions here. I've been chatting on for the better part of 15 or 20 minutes, so we can answer some more at this time if you like.
Sure. I know one of the questions that came in was about the addressing space, right? Because I know you said that it just sort of appears in a different subnet inside your VPC. So how do you end up allocating that space, or do they need to sort of create a landing zone subnet for the appliances to live in?
It's very well documented. It's super easy. What we do is we need a /27. So we take a /27 and we break it into 2 /28s. We do that because that's the smallest VPC, the smallest subnet that we can do in VPC. So if you don't have at least a /27 available anywhere, that'll be a problem. What the solution does when you hit connect and then hit deploy is it scans through the VPC you've connected and looks for a free /27. If it can't find one, it errors out and tells you that you need one. And otherwise, it'll pick a random one in there, usually near the end or the top of a range, and that's how we do it.
Okay, so I could think one of the examples you had some 10.6 space in there. I think that's where it came from, right?
Yeah. So yeah, from my stuff, and the cool thing is with SteelConnect, we actually can do some overlapping subnet stuff. There's some really neat things that we can do there, and we have a bunch more of that stuff coming. So we have a bunch of different problems we can solve, and we have more than a few minutes in a webinar to explain them.
Sure. Is it also possible to deploy the Steelhead into an existing public subnet, or is it going to have to be a new one?
Yeah, so we do have a Steelhead product that does deploy into an existing public subnet, and then you have a few different options available to you as to how do you get traffic into it. The SteelConnect subnet, the SteelConnect solution here, the stack that we deploy, is a gateway, which has a public and private subnet because we're a firewall as well. And then in the private subnet, or the downlink subnet, as you say, that's the place where we deploy the Steelhead, if it's the SteelConnect Steelhead. So there are actually 2 of them.
Cool. And then what does it look like if the actual appliances themselves lose connection to the controller? What impact does that have?
Oh, So actually none at all. So let me just actually clean this map up here real quick. I'll just disconnect that VPC that I've undeployed there, and then I'll answer that question for you. So basically what happens is if the SteelConnect manager was able to, if it was cut off or something like that and you couldn't get to it, nothing would change in your running configuration. So what we do here is the SteelConnect manager is really just an eye in the sky. So things aren't dependent on it. If you wouldn't be able to make config changes or otherwise work with appliances that were offline. But if the SteelConnect manager was to completely explode and not work at all of the things, all of the appliances you have, all of the instances, those would all continue to run with the last configuration indefinitely.
Okay, cool. And then what's the automation story here? You guys have some APIs. Does it work with CloudFormation templates? How would you end up standardizing some things around this?
So today, SteelConnect Manager itself does have an API which allows you to orchestrate many things that we can do in the console, and we're actually adding a bunch of that almost every release. We have a release usually every month with some major stuff coming usually every 3 months, so we're a very fast and agile shop. When it comes to the actual orchestration of Amazon, the API hasn't yet been exposed to that yet, so our own API doesn't yet do our own cloud automation just yet. We do have some very cool features coming later this year to announce at reInvent on how we're going to make that even better. So that's kind of the stuff that we're working on around here to make the deployments go much smoother and in a much more automated way than logging into the SteelConnect Manager itself.
Okay, cool. And then what's there were some questions about the on-premises SteelConnect devices. What's sort of the advantage of using those? Is it just the automation component that you guys take care of the configuration then?
Yeah, so the appliances themselves, when you deploy them, they are fully zero touch. So from the appliances menu here, we still have a couple here in Tokyo, but I think in Denver, we have one of our physical appliances. So this is an SDI 130 box. You plug it in. It basically acts as a router, as a firewall, and it obviously gives you full VPN to the rest of the company. So these are great at branch offices or retail locations that have a very high need to connect to the rest of the company. They also are multi-link capable, so you can plug in different uplinks, and we do balancing and path steering and all sorts of really cool SD-WAN style features. Even better is all of the appliances that we offer are available as a virtual appliance as well. So if I was to add an appliance really quickly, I can create a shadow appliance. This is what you use when you're designing a network offline. I'll just grab one of our products here, and I'll say I want to deploy that in Auckland, which already has an appliance, so it wouldn't let me actually complete that. But what I can do is I can find the virtual appliance here.
I'm not sure if we're seeing your screen, actually. At least I'm not seeing it. I'm seeing a Q&A screen. So
the screen share probably stopped. But yeah, so anyways, the only point I wanted to make was that not only can you look at actual hardware appliances on site, but everything is also available as a virtual appliance on site. And I think, Craig, that was you guys that actually started off using virtual appliances at the beginning, because that's how you got started, right?
Exactly, yes. It was the easiest way just to get straight on, and we're still using those virtual appliances. It sits on our VMware platform. It runs great, and as we expand to our satellite offices where there's no IT, there's no VMware platform, we're going to look into the hardware solution so we can post one plug and done.
Sure. Yeah, so the actual the virtual appliances carry all the same benefits. So if you're dedicated and wanting to plug like internet uplinks into those appliances, they connect you instantly to the cloud. It's kind of like the McDonald's of Direct Connect, so to speak, right? You just plug it in and you don't have to transit through different data centers and stuff. You just get right there over a VPN line, like is possible with Amazon today using their VPN gateway and many third-party products. We just automate it for you. Now, if you aren't looking to replace your gateway at the edge yet, and you just want to run something in the network that acts as a portal into AWS, you could do kind of what Craig did, launch a virtual machine, place it somewhere in the network, and ensure traffic arrives at it. And at that point, it will get transited down into the VPCs and into the other subnets that you have there.
Sure, but if I got an existing, like like you said, ASA or router or Juniper SRX or something like that, I could also do a VPN from that into this infrastructure, right?
Yeah, you could make a classic VPN from the SteelConnect running in AWS and then make a classic VPN to those devices. But of course, here at Riverbed, we engineer our stuff for the eventual replacement of those devices, so we're happy to talk to you about replacing your legacy stuff with something a bit more 21st or even 22nd century.
Sure, okay. So folks on the call, if you guys have any more questions, put them in the Q&A panel here. I think we've gotten through most of the questions here. We've got a couple more coming in, so if you got questions, bring them in. And I'll give you guys a couple minutes to do that. Otherwise, I think we're wrapping this thing up. I don't know.
That's the best part about automation that works, Nick, is that when automation actually works, people don't have any questions because they're like, hey, it works.
I believe in that. Cool. All right, folks. Let's see here. We've got a couple questions here. So can you please show how to deploy the virtual instance of SteelConnect in AWS?
Oh, maybe I wasn't sure on that because we did actually deploy the AWS part in the demo there. That was when we hit the deployment button, it actually spun up an instance in AWS. It connected it to the rest of the network, and the instance itself was happily running. We showed it a couple of times in EC2 there. And yeah, you don't ever have to log into it. It doesn't have its own console. Everything is done from SteelConnect Manager. The whole system was built from the ground up with that manager in mind. It's unlike other products which were built from the ground up to be locally managed in a GUI or a command line, and then the manager is a separate product that came later. So this entire system was architected to be used from SteelConnect Manager.
Okay. Another question was, if they said that you mentioned that people could see the SteelConnect Manager after the call. Is there a way to do that in a simulated way? Or is it sounds like, isn't the simplest option going to be going through Marketplace and just spinning it up in your own account, or is there an easier way to get access to that manager?
Actually, yeah, we'll contact them after the webinar as well, but if you're at a browser right now and you want to get started and beat the rush, you can go to riverbed.com/SteelConnect, and there's a little button there that says free trial. When you click that, what that does is that will cause somebody in our ops team to actually create you your own dedicated SteelConnect manager, and then you can log in and do the AWS onboarding process, like subscribing to the Omnis via the Marketplace and such like that. A very important point is, once you've got your SteelConnect manager and you're logged in, keep in mind they are Marketplace Omnis. So you need to go to the Marketplace and simply click the manual launch button and hit I agree or subscribe. You don't actually have to launch an instance from the Marketplace itself. Once your account is allowed to launch those Omnis, that's the account that will be used by SteelConnect Manager to actually launch them for you on your behalf from the command line. So it's all done through the Marketplace, but you only have to subscribe to things there, and then the manager can do its work.
Sure. And then another question was about the optimization. So what type of traffic, or what kind of AWS traffic can we optimize with the optimization engine?
Oh, we have customers that use it for, I mean, the nice thing about Riverbed is as long as it's not completely unencrypted, and even some of that we can do with some certificate finagling by yourself in the middle, but basically a very common use case is stuff like MongoDB. There's a lot of customers who are synchronizing MongoDB instances around the world, and that can make a huge difference in the traffic that you see and how quick the data deduplication and the data reduction does. So Riverbed is basically the market leader in WAN optimization. It basically optimizes all sorts of traffic, and different types of traffic can be optimized in many different ways, from hundreds of percentage points in reduction to 5 or 6 percentage points if it's already heavily efficient and very, very unoptimizable, so to speak. So you should try it out. It doesn't cost you anything. A few dollars to spin up a couple instances and try moving files between regions or something like that. You can see the difference yourself very quickly.
Cool. And then this question says, can we also spin up a virtual ARX in a similar fashion, or how do you all recommend using the ARX in the cloud? I'm not familiar with ARX. I'm not sure if you are.
It's a great game that my son plays, but I'm not exactly sure if ARX is what he means, but I don't really know what ARX is, so you'd probably have to let us know what that is and I can tell you.
Okay, yeah. The person that asked that, maybe you can just follow up with Angela or myself in an email afterwards. App response expert.
App response. Oh, that's one of the Riverbed products. You see, so yes. Full disclaimer is that even though I work at Riverbed, we have lots of products here, and unfortunately, I'm more on the SteelConnect side, and my head is literally in the cloud all day long, so I apologize for that. SteelConnect does not deploy ARX from the SteelConnect console itself. However, we're currently in the midst of a massive shift of many of our products and services into SteelConnect Manager, so watch for those updates as it happens throughout the next year or two.
All right, and then let's see here. I think that's what we've got. Those are the questions that have come in, so we can give folks a couple minutes of their time back. You will see an email come out with some of the details for the slide share and the recordings. I know we used to do polls and feedback and whatnot, so if that's in the email, then please fill that out. Otherwise, thanks everyone for coming, and appreciate the time.
And thanks everyone for your time today, and a special thank you to Craig from OpenEye for donating his time to us today and telling us a little bit about his company, and that's great, Craig. We really appreciate it.
Yeah, thanks, Craig. That was good. All right, folks, we're going to wrap up here. It was good spending time with you.
Thanks, Nick, and thanks to everybody at Amazon as well.
No problem. See you guys.